Hello, my name is Robert Mertz. I'm an AS&T NDT Level 3. I work with Alta Vista Solutions, and today I will be performing a demonstration on how to perform liquid penetrant testing using solvent removable type. Okay, the reason why we want to do a demonstration on liquid penetrant test is just to explain how to do it properly, and some of the reasons why we do it is for cases where you cannot do magnetic particle testing, such as stainless steels or other materials that are non-ferromagnetic. The first step in the procedure would be to clean the test plate. So the first step, I will take the cleaner. I need to use a lint-free cloth. That's key. You can't use paper towels. You want to use a lint-free cloth. If it's really greasy, dirty, you can spray directly on the plate. This plate is very clean, so I'm going to clean this. Hopefully you're in a nice, well-ventilated area. I don't think you can over-clean at this point. Make sure you get along the toes of the welds very good. And then let that sit for a minute, let that evaporate. Okay, the next step, now that the material or test plate or surface that we're going to examine is clean thoroughly, we want to spray the liquid penetrant. Make sure the can is shaken well. Spray it, just lightly spray it. It doesn't take a whole lot. And we want to let that sit. Depending on the temperature of the base metal, it can be anywhere from 5 to up to 30 minutes. If it's way below 50 degrees, you probably shouldn't even be doing the test. The colder the material is, the longer you need to let it sit. That time that it sits is called the dwell time. So in this case, for the temperature of the base metal and the procedures that we would be following, we would let this dwell for about 8 to 10 minutes. So I'm going to let this dwell, and then we'll come back and do the next step. Okay. The next step, now that we've allowed our penetrant to dwell the proper time, now we want to clean the product off the test plate. And now it's time for some gloves. You can do this without gloves, but I prefer not to for obvious reasons. We'll start out by just trying to wipe the surface off. We want to remove all the penetrant that we can. Try to get it back as clean as it was when we started. Even wipe along the toes of the weld. Try not to leave a lot of that behind. Down in the valleys of the weld reinforcement, try to clean that as good as you can with a good dry lint-free cloth. Okay, the next step would be to actually spray some cleaner onto a rag. Now that I've removed the excess, you want to spray some cleaner on the rag. You never want to spray the cleaner directly onto the test part. You could flush out any penetrant that may be there to expose the defect that you're trying to find. So do not spray directly on the test plate. Spray it on the rag, then wipe it down. I don't know if you can see this, but it cleans it a whole lot better. It gets all the excess off of the toe of the weld, so you don't have a lot of false indications. Okay, that looks good. See how much was left over? Look clean. Okay, give that a minute to evaporate. Okay, now that my test plate is all nice and clean, I've got all the penetrant that's visible removed through a nice clean cloth. Now I want to apply the developer. Make sure that's good and agitated. And it just doesn't take very much. Just spray a light coating on the top. Just dust it. I know it looks like nothing's going on there. As you can see, this is slowly drying. And this will actually, through capillary action, is how the penetrant goes into a defect. This has a blotting agent into it that allows it to extract that from any flaws that would be in the test plate. So give that some time to develop. As you can see, this is drying. This will actually turn into a powder, and you can actually wipe that off when we're eventually done. But right now I'm just looking for flaws to start developing. Okay, now for the last step. Now that we've cleaned it, we've applied our penetrant, we've applied our developer, everything's set the appropriate amount of time. Now it's time to evaluate the weld. So now I'm going to look at the test plate here, and this plate actually looks like it's an acceptable weld. So apparently, you know, with PT, the indications have to be open to the surface. If they're subsurface, this test method will not work. So in case, you know, in this case, the test plate apparently has no flaws that are open to the surface, because I don't see anything that's not supposed to be there, any type of flaws. There may be flaws in there that can be detected by other methods such as ultrasonic testing or magnetic particle testing, because if you were to see a flaw, it would look similar to the type of bleed out that you see across this edge right here. The few little spots that I see, that is due to undercut on the weld, and therefore this weld is an acceptable weld. Okay, now that we've evaluated this weld, and it doesn't have any rejectable indications, so I wanted to show you a test plate that has a rejectable indication in it. Okay, now here's a test plate that we did simultaneously, and it actually has some indications in it. If you look real close right here, you can see some bleed out through the capillary action, and the developer actually is a blotting agent, draws the penetrant out. There it looks like some incomplete fusion along the edge of the weld here. This is just a little bit of overlap. If you look real close, there's actually a real small crack on the toe of this weld on this side here. You actually got a little bit of bleed out here from a little piece of weld spatter. And of course the bleed out on the edges is just where the developer drew the penetrant up along the sides. So this one actually has some indications that need evaluation. Okay, this concludes our training session for liquid penetrant testing using the solvent removable type. Thank you.